Okay, so this is our first chapter, which is chapter for the transcendental functions. Okay, let's look at the outline for this chapter. Okay, so the first one here, we will look at the hyperbolic functions. Okay, so in these hyperbolic functions, we will look at the definition, the graph, and also the identities. Okay, so the next subtopic is the inverse function. Okay, the inverse, we have the inverse trigonometric functions, the inverse trigonometric identities, and then the inverse hyperbolic also, and the log form of the inverse. Okay, so for the inverse hyperbolic function, we have the example like sine x. Okay, so we have the cos x, we have the tangent hx. Okay, so for the inverse trigonometric function, we have like sine inverse x, we have the cos inverse x, we have the tangent inverse x. For the inverse hyperbolic function, we have the sine inverse x, cos inverse x, tangent inverse x. Okay, so these are the functions that we're going to look into this in this chapter. Okay, alright. Now let's look at the hyperbolic function. Okay, so we have here the definition of the hyperbolic function. Okay, so hyperbolic sine, hyperbolic sine is pronounced by as shine. Okay, so we have the sine x is equal to ex minus e minus x over 2. Okay, so this is the definition. When we say that definition, meaning that we need to look at into the exponent lah. Okay, into the with the exponent form. Okay, hyperbolic cosine is pronounced as cos. Okay, so we have cos cos h lah. Okay, cos ex plus, this time plus, yeah. Kalau sine, we have the minus in the middle here, but for the cos, we have the plus in the middle. Okay, hyperbolic tangent, pronounce it as tang ataupun tangent h lah. Okay, which is tangent h x is equal to sine over cos. Okay, sine over cos. Okay, so it is equal to exponent x minus e minus x over ex plus e minus x. And also, if we rearrange that, we will have e to x minus 1 over e to x plus 1. Okay, hyperbolic second, we pronounce it as sec. Okay, so sec x is equal to 1 over cos. Okay, 2 over ex plus e minus x. Okay, hyperbolic cosecant, pronounce it as cosec, which is 1 over sine x, which is equal to 2 over ex minus e minus x. Okay, so basically we know that from cosec here is 1 over sine x. Okay, so basically we know that 1 over, the definition for sine x just now is ex minus e minus x over 2 kan. So after we rearrange, we will have 2 over ex minus e minus x. So that's why we obtain this one here. Okay, so for hyperbolic tangent, we have the cos x over sine x. Okay, so cos x over sine x is equal to ex plus e minus x over ex minus e minus x. Why? Because for cos, we have ex plus e minus x over 2, right? And then we need to over, for sine is ex minus e minus x over 2. So basically we cancel out the 2, therefore we obtain ex plus e minus x over ex minus e minus x. So that's why we obtain this one here as the cotangent h. Okay. Alright, now let's look at the graph of the hyperbolic function. Okay, so we already know the graph for the trigonometric function sine. Okay, so like sine x, this one is a trigonometric function. Okay, so we have the sine x, it will be like this, right? Okay, dot 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 dot, and so on. Okay, for cos x, we have like this. Okay, This is the graph for cos. Okay, and for tangent, okay, what is the graph for tangent? Tangent x. Still remember? Like this, right? Okay, and then we have the asymptote line. Okay, so it repeated. Okay, so we have the asymptote line. Okay, so that one is tangent x, sin x, cos x. So now we want to look at the graph of sine x. Okay, so the hyperbolic function graph, we know that it depends on the ex and e minus x. How do we know that? It is from the definition that we look at it before. Okay, therefore for the graph also is combination of the exponential graph. Okay, so for sine x is like this. Okay, so this is the graph. Okay, so from the graph we can see that, okay, sine 0 is equal to 0. Yes, this is sine 0. So we know that this is graph for sine S and H, sine x. Okay, so this is x, this is y. Okay, so here we know that the value for x is 0. So sine 0 is 0. Okay, so the domain here is all real number. Okay, the domain is refer to the value of x lah. Okay, so here we know that it is all real number. Okay, all real number. Why? Because the value is up to infinity here. Okay, in negative infinity. So kalau for yang ni pun akan up to positive infinity. So meaning that all real numbers lah. Okay, so the curve is symmetrical about origin. Okay, the curve is symmetrical about origin. If you look at here is the symmetry lah. Okay, so for which is sine minus x is equal to minus sine x. Okay, so if symmetrical, this is the graph. Okay, and it is an increasing one-to-one function. So maksudnya increasing one-to-one function from negative to positive. Okay, one-to-one function maksudnya if we have one value of y, we only have one value of x. So for example, if we have one value of x here, we only have one value of y. Okay, so that is one-to-one function. Okay, for graph cos, okay, so this is the graph for cos. Okay, so we can see here, okay, the graph cos 0 is 1. So here is the value for 1 lah. Okay, here is cos 0 equal to 1. Okay, and the domain is all real number also. So if you look at the domain for x, okay, so x is all real number. Okay, why? Because if you look at the value for the x, okay, so up to negative infinity, it is negative infinity lah. So for the positive value also is up to positive infinity. So here pun is up to negative infinity. Okay, the value of cos x is never less than 1. Okay, it's never less than 1 because the minimum value here is 1. So it won't get 0 ke 0.1 ke negative ke, tak ada. Okay, the curve is symmetrical about y axis. So if you look at here, this is y axis. Okay, so it's symmetry about y axis. And it is cos negative x is equal to cos x. Okay, so for any given value of cos x, there are two value of y. So if we have two value of x, so if we have one value of y, there are two value of x. So if you look at here, okay, so we have let's say one value of y, which is 4. So we will obtain two value of x, one value and another value. Okay, so meaning that one value of y, we will obtain two value of x. Okay, alright, meaning that one is not one to one lah. Okay, is we have one and two value. Okay, graph for tangent x. Okay, so this is graph for tangent x. Okay, so we have asymptote line here. Okay, we have asymptote line. Okay, at negative 1 and 1. Okay, and here we have x, y. Okay, so this is a graph for tangent x. Okay, so we know that for tangent 0 is 0. And for the domain here, we can see it is negative infinity. Okay, for x is negative infinity to infinity also. So x is a real number. Okay, so we can see tangent 0 is equal to 0, and tangent x always lies between y equal to minus 1 and y equal to 1, which is this one is asymptote line. Asymptote line. Okay, so the negative x is equal to negative tangent x because it is symmetry about y-axis. Okay, so if you look at here, it is it's symmetric about origin. So if you look at here, it's symmetric about origin lah. So not y-axis, sorry. It's about origin. Okay, and it has a horizontal asymptote y equal to minus 1 to 1. Okay, so tangent x always lies between the asymptote line minus 1 and 1 is give us the range lah. Range for the graph is between minus 1 and 1. So the range are, okay, so basically the y is between minus 1 and 1.